Hey guys, welcome to this week's advanced constant presentation. For this week's experiment, we're going to be making magnetic fluid. So I have here Epson black toner ink. I got here some magnetic hooks I got from Staples. I know it's for I tried getting a hold on the earth magnets, but I ordered on Amazon and they didn't come on time. So I'm gonna be using these hooks. They're basically more or less, as you can see, they have this circular magnetic magnet, and I feel like they might work just as well. And as you can see, they're magnets. So, and last but not least, vegetable oil. And so this week's experiment is pretty straightforward. So I have here a little measuring cup, and all we're going to be doing is we're going to be pouring about 50 milliliters of black toner ink into the cup, 2 tablespoons, and 2 tablespoons of the vegetable oil, and we're going to mix it in there. And with the earth magnets, we're going to be basically testing out the interactions between the magnet and the magnetic fluid. All right, so first I'm going to be pouring some ink into this about 50. As you can see, it's marked the most bottomless line. So here we go. A little more of that. Okay, so this is about 50. And I'm gonna pour it into this container here. All right, so we have 50 milliliters of toner in here. Then we're gonna get some of the vegetable oil, and we're gonna have about 2 tablespoons. Pour some of this in here. And in the video it says we can use a little more than that. I'm just gonna eyeball a little bit. I'm just gonna pour it just a little bit more. Okay. All right, now great. That should do the trick. Guys, so I have in this container the mixture of toner ink and vegetable oil. So the final thing we're gonna do, we're just gonna be mixing it up. Try to make sure it's have that nice consistency. I'm just eyeballing it, trying to make it look like it was in the video. Okay. Now, I'm not sure if you guys can see the consistency of it, but it's a little bit viscous. It's become more, the texture of it seems to be like more sticking together almost. And there's some almost like if you just look at the surface of it, it looks kind of oily. So yeah. So and I chose this cup because it's thin and it's sort of, it's the smallest cup I have. We all have big cups at home, but basically what we're gonna do next is we're gonna be using the magnet and we're gonna be holding it over the container. Now I'm not gonna pour it out because I don't want to make a huge mess in my room, but um, we're gonna be testing this fluid out and see how it works. All right, so I have the magnet, as you can see. Okay, let's see if this works. Let me just hold it over it. All right, so from my observations, I did see that it was attracted to the magnet a little bit, but unlike the video, I didn't see the little spikes that the ferrofluid was supposed to make. Um, Honestly, I'm a little disappointed, but I don't know why, uh, what went wrong. It could have been maybe the fact that I wasn't using the earth magnet in the video, but I thought that, these would basically be the same, but it's not really. As you can see, I'm sort of seeing like a little bit of attraction. There's definitely some attraction. Like I definitely see some attraction, but it's not as, I guess, super attracted or forming those spikes as was shown in the video. Yeah, I'm not too sure why, but like this is an experiment. Things, fails do happen, but um, possible, um, poss- you know, possible errors could be maybe my ratio of the fluid and the ink toner. Um, there's just so many variables. I got my ink toner Epson. I saw some videos used a powder and they mixed with the oil, but I try to replicate it as much as it was in the video. I saw they use a liquid, so I use a liquid, and I used um, 2 tablespoons of vegetable oil, but um, it's not really having the same result, but that's okay. Observations that I can make, however, is that when the um, fluid is just free floating by itself, without the external magnet over it, you know, it's it's quite stationary. Um, it, it's consistent with it within itself. There's no movement, but with the external magnet over it, I did see some interaction of hinting or at its magnetism. So I can see like at a certain angle the spikes, but just not to the same effect as it was in the video. But I'm still going to be breaking the concept and why this happens now. Okay, so what is ferrofluid? Ferrofluid is a magnetic fluid or a fluid that contains a magnetic suspension. Now, uh, the main principle behind it or ingredient is magnetite, and it's the main ingredient that is used in toner. And the liquid contains tiny particles of magnetite, Fe3O4, which is mixed iron oxide. And iron oxide has the property of magnetic attraction, which is why there's attraction between it and a magnet. And well, what is magnetism? So I did some research. Magnetism is basically it's the force exerted by magnets when they attract or repel each other. And magnetism is essentially caused by the motion of electric charges. So every substance we know is made up of tiny units, atoms, and each atoms have electrons, and which are particles that create an electric charge. And these electrons, they're spinning like tops. They circle or orbit nucleus or the center of the atom, and this movement, it generates an electric current and causes each electron to act like a microscopic magnet and to become magnetized. Another strongly magnetic substance must enter the magnetic field of an existing magnet, and the magnetic field is the area around a magnet that has magnetic force. So we know that in fifth grade science, the North Pole, South Pole, and the force generated by the aligned atoms is what creates a magnetic field, and the piece of iron becomes a magnet. In summary, the reason why the fluid we create with vegetable oil and the ink toner is magnetic because the laser jet printer toner creates it contains iron ball ink that contains dissolved iron particles, or as we said, magnite. So basically, the laserjet printer contains the magnetized drum that the printing paper runs over, and the drum pulls the ink onto the paper. So yeah, iron is super magnetic, as we know, as we discussed earlier. So when it is mixed with a fluid, you have a magnetic fluid, or as we mentioned earlier, a fluid with magnetic suspension. So in short, the iron in the ink is what makes it magnetic and magnetized. So that's basically the 6 weeks experiment. Um, Things that can be improved on is definitely um, maybe getting the rare earth magnet. Maybe the magnet is a little different and how strong it is. Um, just trying to be more proper and consistent with measurements. I used uh, uh, measuring cup, and just trying to standardize everything and repeats multiple trials that can ensure the um, accurate, more accurate results in this experiment. But that's basically it. Thanks for watching. I'm happy to have shared with you this experiment and my observations on it. I'll see you guys next time.